This is Chapter 7, Lesson 6, Homework Practice. We're going to solve one-step inequalities. So we're used to solving one-step equations. Now we're going to talk about inequalities. Not a whole lot of difference, just a little bit. You're going to have to put them on a number line. So as I work with you on these problems, I'll be kind of going over what was taught in class to help reteach it. We're going to do the odds. So number 1, you have n plus 5 is less than 7. So again, we're going to solve like we would a normal one-step equation. I want to get all my whole numbers together. I want to get the variable all by itself. So basically, we're going to do the adding and subtracting first. And this is a positive 5, so to cancel it out, to make it 0, you need to subtract 5 from both sides. This cancels out, brings it down to n equals, less than. Inequalities, that's the big difference. There's no equal sign. N is less than, and you have a positive 7 and negative 5. So these 5 negatives are going to cancel out 5 positives. And you're left with 2. Now then, to draw that on your number line, you're going to ask yourself, can n be 2? Because it says n is less than 2. So I'm going to go and just go ahead and kind of circle where it should fall. And then ask myself, can n be 2? No, it cannot, because it doesn't equal 2. It's n is less than 2. So look at your number line and say, which one is less than 2? Is 1 less than 2 or is 3 less than 2? 1 is less than 2. So you're going to shade it in this way. Okay, it can be any number less than 2. 1.999, it could be n, but not 2. I'm going to skip on down. Let's go to 5. Four is less than or equal to s minus 3/4. So again, I want to get all my numbers on one side. I want to get it away from the variable. So if I have a negative 3/4, I'm going to need to add 3/4 to cancel it out on this side. So I'm left with s is less than, well, I'm reading it backwards. S is less than or equal to. So over here on 4, I want to add 3/4. We're going to add it. So remember, when you are adding fractions, you must find a common denominator. So 3/4 plus, I need to make this a 4, so I'm going to multiply it by 4, multiply this by 4. Okay, so if you do 4 times 4, you should get 16. So since I'm adding them together, just add straight across and keep your common denominator. So 16 plus 3 should be 19. Now this is an improper fraction, so you're going to need to change it to a mixed number so we can put it on the number line. So it would be 19 divided by 4. That can go in there 4 times. And we're going to put a decimal there and bring down a 0. And it should be 4.75. So 4.75 is greater than or equal to s. Okay, if we want to flip it where we read it, s would be, you can either read it backwards or we can just flip everything. I could read s is less than or equal to 4.75. Or I can flip everything. S is less than or equal to 4.75. Those are the same answers. Okay, you can either read it backwards or flip everything and read it forwards. So let's find this on your number line. There's 4, there's 5, and it's about, 3/4 is 0.75. So I would say it's about right there before you get to 5. Now ask yourself, can S be 4.75? Can S be 4.75? Because it reads, S is less than or equal to 4.75. So yes, because of the equal to, we're going to color it in because it can be 4.75. But it's going to be less than or equal to. So which one on the number line is less than? Is it 4? Is that less than this? Or is 5? And it's going to be 4. So we're going to shade it in. Here's another secret. As long as your variable is on the left-hand side, the line on your number line is going to point in the direction of your inequality. So if you look, S is on my left, your inequality is pointing to the S, it's going to go left. Your N is on the left-hand side because it must be on the left-hand side for this to work. Then your inequality points in the same direction. That's just a little trivia to help you out. But again, the variable must be on the left-hand side. Let's look at number 7. You have -8 is less than or equal to 8W. Nope, this wasn't the one I was wanting. So, all right, so divide by 8 and everything stays good. -8 divided by 8 would be a -1. So find -1 on your number line. I'm just going to circle it, then ask, can W be -1? Okay, again, I'm going to switch everything over just because it reads better. So I'm going to flip everything over. So W is greater than or equal to -1. Okay, so W can be -1, greater than, equal to -1. If it can be -1, you're going to color it in. So W is greater than or equal to -1. So can W be greater than? Would it be -2 or 0? And 0 is greater than -1. So you're colored it in this way. And again, my variable's on the left, my inequality is pointing to my right, and so that's the way it went. All right, I'm doing a lot more of these than I wanted to for you guys. But let's look at number 9. Number 9 is a little different. -25t is less than equal to -500. Okay, there's a special rule when we're going to divide or multiply by a negative with inequalities. So to get -25 off of t, because I want my variable by itself, you find the variable and you ask, what is it doing? It's multiplying. So you need to do the opposite, which is divide by a -25, both sides. Now when you do that, when you carry a negative, when you're carrying this negative over, it is going to affect your inequality. Your inequality switches, okay? So it's going to be now facing this way. So I would do that before you did anything else, because I don't want you to forget that. Your inequality switches. When you divide and multiply by negative, you're going to change your inequality sign. This cancels out and leaves you with t, which is what we want. So now you have negative 500 divided by a negative 25. Your answer will be a positive. Negative divided by a negative is a positive. But be aware of flipping your inequality. Okay, let's look at number 11. You have m over negative 8 is less than equal to a negative 2.4. So again, find your variable, and my variable is m. What is it doing? It's being divided by negative 8. So I need to do the opposite to get it off, which is multiplying by the reciprocal. Negative 8 over 1 cancels out, leaves me with m. Okay, if I'm going to bring this over and I'm going to multiply by a negative 8, it does, oh, wait. It's going to switch your inequality. Okay, so because we brought over the negative 8, we're going to multiply by it. So let's go ahead and change the inequality. Okay. And then a negative 2.4 times negative 8. Your answer will be positive. Okay? And a lot of you are messing up with your decimals. So let's go ahead and look at this. I'll work it out over here. We still have to work really hard with your decimals. 2.4 times 8. I want you to multiply it out and then add your decimal. Okay, so 8 times 4 is 32. Then you have 2 times 8, which would be 16, plus 3 would be 19. Now then, don't forget your decimal. You have your decimal right here. You need to move it one spot. So we bring it down here and move it one spot. So m is going to be greater than or equal to 19.2. Now you have to go back and put these on your number line, but just remember to ask yourself, can m equal 19.2? Well, it says m is greater than or less than 19.2. Okay, keep asking yourself those questions that I asked at the beginning of the homework, and then make sure you're putting them on your number line. Number 13. Sandy has at most 68 envelopes to address. He has addressed 17 of them. Write and solve an inequality that describes how many more envelopes at most Sammy has left to address. Okay, so we have 68 envelopes to address. So my total needs to be 68. He's already addressed 17 of them. We want to know how many does he have left. Well, we know the total is going to be 68. We know he has addressed 17, but then whatever he has left, he still has to, we have to add that to get to 68. Now then, how many more envelopes at most does he have to address? He could do more, or he could do more, but at most. So it would be greater than or equal to. Okay, there is your equation. I want you to solve it. It's a one-step equation. Your answer will be in envelopes. So when you write your answer, it should be here and it should be envelopes. Okay, we make sure we always label our word problems. Okay, let's look at number 1 on the back. Number 1 on the back. Luella is driving from Melbourne to Pensacola, a distance of more than 500 miles. After driving 240 miles, Luella stops for lunch. Write and solve an inequality to determine how much further Luella has to drive to reach Pensacola. Okay, more than. So I already know that's going to be more than 500. Okay, and then we know that she drove 240 plus however many more miles she has to go. And that's what we're going to find out is N. So another simple one-step inequality, but I did help you set it up. Number 3. Vikram and 4 of his friends are planning to split a pizza. They want to spend at most $4 per person. At most. Okay. Write and solve an inequality to determine the maximum cost of the pizza they can order. So they cannot order more than $4 per person. At most $4. Okay, I'm just going to go ahead and do it on this piece of paper. So we have at most, so it needs to be okay, let me write it the other way. At most. So your cost has to be less than or equal to whatever they're going to spend on their pizza. Okay, because it can't go over. So their cost has to be less than or equal to. It cannot go over $4 per person. So $4 per person. How many people are there? 4 and him. So that would be 5. Okay. So at most, how much money per person? Okay. Number 5. Vance wants to have pictures framed. Each frame and mat costs $32. He has at most $150 to spend. So again, at most. So less than or equal to $150 to spend. Write and solve an inequality to determine the number of pictures he can be framed. So $32 for each frame and mat. So how many pictures can he do? Okay. I'm thinking about it. She may have wanted you to set this one up differently, but I think that'll give you the same. Because if we're solving for one-step equations, that's not even a one-step. It's just multiplying and you have your answer. But anyway, that's the way I would have set it up. She may have set it up differently. But I think we can agree on this one. So at most, how many pictures? Okay, you're going to get a decimal on this one, but you can't frame part of a picture. Okay, so you're not rounding up. You would definitely have to go down, okay, to have a whole number. So just a warning, that one will give you a decimal. But your answer here is not a decimal, but show your work. Number 7. Julius is allowed to surf the internet for only 3 hours a week. He has already been online for 1 and 2/3 hours this week. Write and solve an inequality to determine how much more time Julius can spend on time this week. So again, He is allowed 3 hours. Okay? So X can be less than or equal to, but okay, hold on. Sorry. So this has to be less than or equal to the 3 hours. So how much time can he spend if he's already spent one? Why did I say 1.5? I believe it's 2/3. Okay, I think that's how I'd set that one up. So X plus the time he already spent can be less than or equal to 3. So how much more time can he spend? So this is how much more time he can spend, but this is how much he's already spent. Okay, there's another way we can set it up, but I'm thinking this is the way she wants it. And it would be hours. Your answer would be hours left to spend online if you want. Okay. If you have any questions, ask them on Google Docs, or you can come in the morning for tutoring.